logarithmic functions. The inverse function of the exponential function with base b is called the logarithmic function with base b. Consider 3 power x equal to 27. How do we solve for x? So here on this part, we have this type of questions. Definition of logarithmic functions. A function of the form f of x equal to log x is called a logarithmic function if b greater than 0 and b is not equal to 1 and x is greater than 0. So log x is equal to y means here we have b, so that is base. B to the power is y, that is equal to what we have here on this slide. So this is equal to x. Example, log 8 equal to 3, here base is 2. So we have 2 cube, that is equal to 8. So 2 cube equal to 8. Basic logarithmic properties. Number 1, here we have log, base is b. On this part again we have b. So b power 1 is equal to b. Number 2, here again base is b. I should have power 0, so that way I can have this one equal to 1. So what that means here on this part, log a is equal to 0. Number 3, here again base is b. The answer is b to the x power. So here we have b to the x power for our answer. Here was what we had for the base. And based on that, we want to see what we're going to have here on this part based on what I should have here. Because of having x on this side, I should have same thing on this part. So b to the x power is equal to b to the x power. So our answer here is x. Number 4, b power is log x. So on this part, we have b, and here we have b. So we can cancel these. So it cancels, and our answer here is what we have on this part, so that is x. In fact, if b to the x power equal to b to the y power, what that means, because of having same base, use what we have for powers, these two should be equal to. So we have x equal to y. Rewrite the following in exponential form. Log, here base is 7. So we have 7. Here use this number as a power. So 7 squared equal to what we have here on this part. So equal to 49. Number 2, here base is 8. Power is -1 equal to what we have here. So 1 over 8. Now here base is 27. Power 1/3. So what this means, we have cube roots of 27, and that is equal to 3, and this is what we have here. So 27 power 1/3 is equal to 3. Rewrite the following as a logarithmic equation. Number 1, here we have 3, power is 4. So 3 to the 4th power is equal to 81. So logarithmic function, the number that we have here, that is our base. What we have here on the right side is here, and then that is equal to what we have here as a power, but this is equal to 4. Number 2, log, here we have 2 as our base, Then this number is here, 1/8. So log is equal to what we have here, 4 power, so that is -3. Number 3, log. Here we have 7, so that is base. This is equal to cube roots of 7, so writing that here on this part. And then this is equal to what we have here as a power, that is 1/3. Number 4, log base is 10. This is equal to 1, so writing 1 here. And then log is equal to power is 0. So log is 0. Evaluate the following logarithms. Number 1. So here we have log 125, base is 5. Since 5 cubed is equal to 125, this is equal to 3. Number 2, base is 2. Here we have 1/4. Since 2 to the power -2 is equal to 1/2 squared, so that is equal to 1/4. So here we have 1/4. This is equal to what we use for power here on this part is -2. So the answer is -2. Number 3, we have log 1000 base is 10. So this is equal to 10 cube is equal to 1000. So the answer here is 3. Number 4, square root of 5. So here on this part we have square root of 5. Here base is 5. So this is equal to 1/2. Number 5, here base 9. Power 1 equal to 9. So the answer for log is equal to 1. Now here what we have is log 1. So this is equal to 7. Power should be 0. So 7 power 0 is equal to 1. So the answer here is 0. Number 7, on the spot we have 1/2, base is 2. So this is equal to 2 power -1. So 2 power -1, that is equal to 1/2. So the answer is -1. Number 8, so base is 16. Square root of 16 is what we have here on the spot is 4. So square root of 16 or 16 power 1/2. That is equal to 4. So this is equal to 1/2. Number 9, here we have 1/100 and base is 10. So 10 power -2, that is equal to 1/100. Number 10, Here we have 3, here we have 3. We can cancel these. So the answer is what's left here. So that is x number 11. Here we have 6. Here we have same number 6. So it cancels. What's left? We have x. So the answer is x. Graphing logarithmic function. The logarithmic function y equal to log x is the inverse of the exponential function y equal to b to the x power. So here on this part we have y equal to b to the x power. For x I have 0, 1. So 0 here instead of x, we're going to have b power 0 is equal to 1. And then on this part, we have x is equal to 1. So b x1. For y, we have b. And then for log, for x, I use 1. So here is 1. So b to the power 0, that is equal to 1. So y is 0. And then here x is b. And this part b. We're going to have b to the power 1, that is equal to b. And here we have 1. And what we have for y equal to b to the x power, we're going to have horizontal asymptote, and that is y equal to 0. And for log, we have vertical asymptote and x equal to 0. So here I have graph these two based on the 2 points that we have for each one. On this part, we have y equal to b to the x power. This graph getting closer and closer to x-axis. So based on that, we have horizontal asymptote getting closer to this line, and that is y equal to 0. So that's why we have horizontal asymptote. And then this is y equal to log, and I have these 2 points, 1, 0, and b, comma 1. Connect these 2 points. This graph getting closer and closer to this line, and this is x equal to 0, meaning that we have vertical asymptote and it's x equal to 0. So these two graphs are inverses based on this line that I have here, y equal to x. So on this point, we can mirror that to the other side on this graph. And here we have 90 degrees. And this point, we can mirror it on that part, and this graph for log. Here again, we have 90 degrees. So we mirrored using y equal to x, meaning that these two graphs are inverses. In general, the graph of f of x equal to log x has no y-intercept. Number 2, x-intercept is at 1, 0, and we have vertical asymptote, and that is x equal to 0. Domain is 0, infinite, and range is negative infinite, positive infinite. So what we had for our graph log, we had this point 1, 0, and we had another one b, 1. So connecting these 2 points, this graph getting closer and closer to this line, and that is x equal to 0, meaning that vertical asymptote is x equal to 0. So this is vertical asymptote. Note that we cannot take logs of negative numbers. Graph f of x equal to log x basis 2. We write this function in exponential form. So let y equal to f of x. What we have here, y equal to log x basis 2. So based on what we have here, writing in exponential form, we have 2 power y equal to x. Now here we have x, y. I'm using -2, -1, 0, 1, 2 for y, and then finding the answer for x. So instead of y, we have -2, so 2 power -2, that is equal to 1 over 4. Then here we have -1 instead of y, so we have 2 power -1, that is equal to 1 over 2. Then y is 0, so 2 power 0, that is equal to 1. Then 2 power 1 is equal to 2. And here we have y2, so we have 2 to the second power is equal to 4. Now graph this function, connect these points, and based on what we have here, this graph getting closer and closer to x equal to 0, meaning that vertical asymptote is x equal to 0. Graph f of x equal to log x basis 4. Rewrite this function, let y equal to f of x. So we have y equal to log x, and writing in exponential form, we have 4 power y equal to x. And then here first plug in what we have for y. So I'm choosing to have -2, -1, 0, 1, 2 for y. And based on that, find x. So we have 4 power -2, that is 1 over 4 positive power, so it's 1 over 16. Then here we have -1, so 4 power -1. We have negative exponent, move that to denominator to make it positive, so 4 positive 1 is power, that is 1/4. Then we have 0, so 4 power 0 is equal to 1. Here we have 1, so 4 power 1 is equal to 4. Here we have 2, so 4 squared is equal to 16. So connect all these points, our graph getting closer and closer to x equal to 0, meaning that vertical asymptote is x equal to 0. Solving logarithmic equations. Many logarithmic equations can be solved by rewriting them as equivalent exponential equations. Examples, solve the following logarithmic equations. Number 1, we have log x equal to -3 basis 2, so 2 power -3 is equal to x. So 2 power -3 is 1 over 2 cubed, and that is 1 over 8. So answer for x is 1 over 8. Number 2, log 16 equal to 2. Here basis x. So x squared equal to 16. Solving for x, we have to use the square root. So on the right side we have negative positive square root of 16. So x is equal to 4, or x equal to -4. But here in this case, our answer is positive 4 because we cannot have negative base. So we cannot have negative base, meaning that answer is equal to 4. Number 3, here base is 10. Power x equal to 1000. So 10 power x, 1000 is 10 cube. We have same base 10, 10. What we have on top as a power, we have x equal to 3. So this power equal to what we have on right side. Number 4, base is x. Here power 1 over 2. And that is equal to 7. So the square root of x is equal to 7. Here we have square root, so use power 2 to eliminate radicals. So we have x equal to 7 squared, and that is 49. So the answer is 49.